Assalamualaikum to our beloved lecturer for this subject, Dr. Nur Rahman. Hi Doctor, I am Hasnina binti Hasim with metric number D2020109566N. So, in this video, I'm going to explain about the solution for the system of linear equation, which is a Gauss-Seidel method. So, I'm going to solve this example by hand using Gauss-Seidel method. So, let's start our explanation. Okay. So there are examples that we found on lecture notes. So given that the following system of linear equation, just you can see it on your screen. So this kind of system of linear equation you can solve by using Gauss-Seidel method, Gauss elimination, Jacobi method, and many more. But in this video, I'm going to explain about the Gauss-Seidel method. So we have 5x1 minus 2x2 plus 3x3 equal to negative 1, and second equation is negative 3x1 plus 9x2 plus x3 equal to 2. And the last equation is 2x1 minus x2 minus 7x3 is equal to 3. So this kind of linear equation, the first step you need to do if you found this kind of linear equation, you need to rearrange each linear equation so that you make sure the left hand side can be a single variable, has x1, x2, and x3. So from the first equation, we get x1 equal to 1 over 5 is multiplied by negative 1 plus 2x2 minus 3x3. And from the second equation, we get x2 is equal to 1 over 9 multiplied by 2 plus 3x1 minus x3. And the last one, from the last equation, we get x3 is equal to negative 1 over 7 multiplied by 3 minus 2x1 plus x2. So from this form, we need to modify this equation using Gauss-Seidel method formula. So for this next step, we get for the first equation, from the first equation, we get x1 n plus 1 is equal to 1 over 5 multiplied by negative 1 plus 2x2 n minus 3x3 n. So second equation, we get x2 n plus 1 is equal to 1 over 9 multiplied by 2 plus 3x1 n plus 1 minus x3 n. And the last equation, we have x3 n plus 1 is equal to negative 1 over 7 multiplied by 3 minus 2x1 n plus 1 plus x2 n plus 1. So this Gauss-Seidel method formula is related each other, which is when you get the value of x1, so you need to substitute the new value x1 into the equation number 2. And after you get the new value of x2, you need to substitute that into x3, equation 3. So you need to find x1 for first and substitute the value into x2, and you get the answer for value x2, you need to substitute that into the x3. So that is a Gauss-Seidel method formula. So for the first iteration, we need to substitute the initial approximation. But since we don't know the actual solution, so we let the initial approximation, which is we let x1 0 is equal to 0 and x2 0 is equal to 0 and x3 0 is equal to 0. So this value, we need to substitute the initial approximation value to the equation system above for find the iteration. So for the next step, we need to find first iteration. So let's start. Okay. So for the first iteration, we use the Gauss-Seidel formula that we modified just now. So we substitute the value of 0 into the first equation. So after we substitute, we get 1 over 5 multiplied by negative 1 plus 2 open bracket 0 and minus 3 open bracket 0 close bracket. So this, after we calculate, we get the value of x11 is equal to negative 0.2. So this value, negative 0.2, we need to substitute into the next value to find x2, which is x21 is equal to 1 over 9 multiplied by 2 plus 3 open bracket negative 0.2, and the initial value of x30 is 0. So after we calculate, we get x21 is equal to 0.155556. So this value, x11 negative 0.2 and x21 is equal to 0.15556, we need to substitute this value into the third equation. So we get the equation is negative 1/7 multiplied by 3 minus 2 open bracket negative 0.2 close bracket plus 0.15556. So we calculate it and we get the answer for x3 1 is equal to negative 0.507937. So this value for x3 we need to use for the second iteration. So since we find this iteration until the value converge to one value, so we need to stop the calculation so that we can conclude the value of x1, x2, x3. So since the first iteration we cannot to get the answer, so we move to second iteration. So continue the step until we get the value of x1, x2, and x3. So after we conduct the second iteration, still not to converge into two value, so we conduct for the third iteration. So if we look to the value still not converge, conduct for the fourth iteration. So after we conduct the fourth iteration also not converge to one value, we need to conduct the same step until we get the answer. So after I calculate that, I get for 7 iteration and 8 iteration, the value started to converge to one value. So since the value start to converge to one value, so we will stop the calculation, then conclude the final answer. So for the final answer, we need to show on in a following table. So we easy to make a conclusion. So we need to put the value of n and x1 and x2 and x3. So we can see that the iteration stop at iteration with value of x1 is equal to 0.186120 and x2 is equal to 0.331230, and for the last one x3 is equal to negative 0.422713. So this is the final answer for this question. So that's how you conduct the Gauss-Seidel method to solve the system of linear equation. So that's all for me. I hope you understand what I explained just now. So alright, that's all from me. So I will pass this video to the next presenter, Said, to explain the same Gauss-Seidel method but using mathematical coding. So hopefully we can see you in the next video.
Assalamualaikum and hi everyone. Now we are going to solve the linear system, but now we are going to use Mathematica. Alright, okay, now this is the left hand side of the system. I call it as matrix A, and this is the right hand side of the matrix system. I call it as matrix B. Okay, and then the initial value I put it as 0 matrix. Alright, so by referring to the formula, we can see here that we need to take out the value of the diagonal, the lower triangularized and the upper triangularized. Okay, now firstly I take out the lower triangularized. Oh sorry, this is not lower triangularized, this is the diagonal. So the diagonal of matrix A. Alright, so then by pressing shift enter, we'll get the output. Okay, this is the diagonal, but this diagonal is not in matrix form. So what I'm gonna do here is I'm gonna give a command to make the diagonal into matrix form. So diagonal matrix of matrix D1. Alright, shift enter. Then the formula also tell us that we need to take out the lower triangularized and the upper triangularized, right? So I'm gonna take out the lower triangularized by using capital L, lower triangularized of matrix A minus D1. Oops, sorry, minus D2, diagonal. Alright, press shift enter. Okay, this is the lower triangularized. Okay, now I'm gonna take out the upper triangularized and use capital U, upper triangularized of matrix A minus D2. Okay, shift enter. Okay, we use minus d2 here because we don't want to make the diagonal included in the lower triangularized and the upper triangularized. Okay, so that's why we need to minus d2 here in both L and U, right? So now in the formula we also can see that there is the d minus L. So to make the calculation easier, by using by looking to the formula, we can see that there is d plus L, right? So to make our calculation easier, so I make it as one term. So I use just a random capital, use capital Y. Y equals to the diagonal plus lower triangularized. Alright. So this is the D plus L, the diagonal plus lower triangularized. Okay, now we are ready to do the iteration because we already have the U, D, and L, the diagonal, lower triangularized, and upper triangularized. Okay, now this is the coding for do the iteration. Okay, shift enter. Okay, this is gonna be the iteration. This is the first iteration. Second iteration. Now let's see when will it gonna converge. Okay, so here we can see that the 8 and 9 iteration already show the same value, so it converges it not at 8 iteration. So it converges at 8 iteration. So that's all. Okay, maybe you are wondering why the iteration is a bit more iteration than by using hand that shown by Hasina. This is because this Mathematica, here you can see that it only show 5 decimal places, but Hasina is using 6 decimal places, though, so it's gonna be we call it as truncation error, the error of when we rounding off a number. Okay, that's all. Thank you.
Hello, my name is Dila Shanka and I join today our present solution for the system of linear equation Jacobi by hands. Given that following system of linear equation is 5x1 minus 2x2 plus 3x3 equal to -1, -3x1 plus 9x2 plus x2 equal to 2, 2x1 minus x2 minus 7x3 equal to 3. In first step, we need to write the system in the form x1 equal to 1 over 5 multiplied with -1 plus 2x2 -3 x3, x2 equal to 1 over 9 multiplied with 2 plus 3 x1 minus x3, and x3 equal to -1 over 7 multiplied with 3 minus 2 x1 plus x2. In step 2, the initial position that we choose is x1, x2, and x3 is equal to 0. Substitute the value of x1, x2, and x3 into this system form, which is the first approximation. We get the answer of x1 equal to 0.91746. Value of x2 is equal to 0.32 at 395, and value of x3 is equal to -0.45 at 72. Continue the step 1 by substituting the new value of x1, x2, and x3 into the next iteration until the iteration converge. Since the values start to converge to one value, so we will stop the calculation and conclude the final answer. Hence, the sequence of approximation that we obtain is shown in the table following. The iteration is stopped at 11 iteration, whereas the value is equal to 0.1 at 6120, x2 is equal to 0.331230, and x3 is equal to -0.422713. In conclusion, Jacobi method is an iterative algorithm for determining the solution of a strictly diagonally dominant system of a linear equation. In this diagram, it's shown the Gauss-Seidel formula and Jacobi formula. Gauss-Seidel formula is different to Jacobi formula. For example, we choose the initial approximation is 0 because we don't know the actual solution. Then we can modify the system using Gauss-Seidel method formula, which is x1 power of n plus 1 equal to 1 over 5 multiplied with -1 plus 2x2 power n minus 3x3 power n, x2 power n plus 1 equal to 1 over 9 multiplied with 2 plus 3x1 power n plus 1 minus x3 power n, x3 n plus 1 equal to -1 over 7 multiplied with 3 minus 2x1 power n plus 1 plus x2 n plus 1.
to find the x2 and x3, we need to find the value of x1 first. And to find the x3, we need to find the value of x3 and x2 because we don't know the actual value solution of this system of linear. So this step is keep continue until we get the converge value for system of linear. It's different compared to Jacobi formula, which is, for example, we choose the initial approximation is 0. Then we only need to substitute the x1, x2, and x3 into the system until we get the converge value in this system of linear. Iteration of Gauss-Seidel method stop at n with value of x1 equal to 0.18612, x2 equal to 0.333, 1230, and x3 is equal to negative 0.422713, while Jacobi method stop at 11 iteration, whereas the value of x1 equal to 0.18612, x2 equal to 0.331230, and x3 is equal to negative 0.422713. This is shown that Gauss-Seidel method is more accurate and faster than Jacobi method to get the conversion value.
Okay, so Assalamualaikum and hi Dr. Akmal. My name is Farah Adila binti Azim with the matrix number D2020109568. So I will be explaining the solution for the system of linear equations by using Jacobi and by programming software that is Mathematica. So in this slot section, so I will be compare which methods is the best to use, where it is fastest method to iterate. So first I will be saying that in this coding by using Jacobi, there we will not be finding y equals to d2 plus l, which is y equals to diagonal matrix d1 plus lower triangularized matrix A minus d2. So in that case we will not be finding it, and there will be a difference in the do matrix, do coding, which is linear solve. We will not put as y, we will not put as y, we will put as d2. And when we run the coding, we will get that the system of linear equations will be converged at the 12 iterations, which is it takes much longer to run the coding than the Gauss-Seidel methods. So we will see that Gauss-Seidel matrix is the best method and the fastest methods to to converge the system of linear equations. So that's all for me. Thank you.